They built about 250 houses using hand-rammed soil cement blocks. This was, I think, during the period of one Mr. Madhavan, an engineer. He was instrumental in taking this idea forward. In Jayanagar fourth block, there were some houses, and near the railway station, there were some houses built. This was again in the 1949, without using any machine. So no burning in both the constructions. Even today, one can witness some few residences near the railway station platform road. But however, the fourth block buildings were demolished and some multi-story quarters have come up. But after this, there was a lull. Nobody took it forward. I think people felt, well, using mud as a material for construction is something which is very primitive and it will not last long and things like that. Now you can see most of these houses in Karnal, they are all being used today, and even some of the houses are still there in Bangalore. So you can look at about 70 years it has performed. So that's when Astra, which was founded in 1974 by Professor Amulya and other scientists, including Professor K.S. Jagdish, looked at stabilized mud block or soil cement blocks as an alternative for burn brick, because burn brick consumes a lot of energy. So we have some examples in IAC. 1976, a biogas lab was done. Then 1985, Astra Office Complex. So during this period, quite a bit of research and development activities happened in IAC. I was working with this group headed by Professor K.S. Jagdish, and we got an opportunity to understand mud as a building material. And there is no plastering involved. Local soil can be used and one can make it. We will look into the details later, how these blocks are being made. I'm just sharing some introductory note to begin with so that you get an understanding of how this technology has spread. So from 1948 or 49 till 1976, there was no support for this technology. I think nobody used it except for some sporadic one or two buildings. So that's when Institute of Science had this Center for Astra. Now it is called Center for Sustainable Technologies. Took it seriously, and a lot of research was done to understand how to take this forward. And today we know very much the kind of issues we are facing, whether it is carbon dioxide emission or look at the carbon footprint. Some people say global warming. Well, these are all, information which is available in the net. One can see how the development has taken place and what we are today, the kind of problems what we are facing. So we are now talking about green buildings. So this particular situation is something we should try to question and see. Can we slow down and see what we should do to conserve, resources, to have a better earth for our living. So it's in our own interest. We need to look at embodied energy in buildings. What do we do here? We try to understand the materials and see what kind of energy input is necessary. For example, burn brick. You need quite a bit of fuel, whether it is coal or firewood. It relates to around 4 megajoules per brick. So, is there an alternative for it? Is the question. Then you look at steel production, it consumes about 4 megajoules per kg. Steel, 28 megajoules per kg. Sand and aggregates also, consume energy. Glass consumes 16 megajoules per kg. I mean, this is interesting to understand. When glass is used in a situation like Bangalore, when summer temperatures rise to around 36 degrees centigrade, how do you look at the building performance? Glass, allows light and also allows heat. So the issue is that we heat the building and then have air conditioning to cool it. Our energy costs are going to be much, much higher. So is it an intelligent way of designing buildings? In cold countries, maybe Western countries where the temperatures are less, they use glass to heat the building. Many a times they call it solar room. So their requirement is different. They have to reduce the consumption of energy in terms of heating the building. But I don't know why we are using too much of glass, and glass consumes so much embodied energy. So all these lead us to look back and understand what is it we should look at. Mud as a building material, why not? So how do we look at this issue? We will look into the techniques of stabilized mud as an alternative to burn brick. So what happens here? Cement and lime gets used as stabilizer. There is no burning. Reduced embodied energy. Using cement and lime, and if we quantify the energy required to stabilize the mud, we use very less of cement and lime, which relates to about 30% of the energy what is going into burn brick. So we conserve 70% of the energy what is used in making burn brick. No plastering and no painting. That is another interesting area wherein we can reduce cost, we can also reduce the material consumption. Very good wet strength and very durable. This is possible. We can definitely get a very good stabilized mud block or stabilized or any other mud technique also, which will give us the required wet strength and the durability. But it is good to understand when. Sorry. Oh, I see. I think there is. Are you able to view every slide properly, or is there?
Yes, sir. The screen is visible. We have the screen is visible.
Okay. Full screen is visible. Okay.
Last
2 points like plastering and painting are required. Good wet strength. Okay. If it is visible, then it's fine. Otherwise,
sir, Yogananda sir.
Yeah.
Yogananda sir, I'm very sorry to interrupt you at this juncture. We have ICI Secretary Dr. LR Ramesh with us, RL Ramesh with us.
Okay.
He would like to just speak about the event for just 2 minutes, after which we can continue. I'm very sorry for this unfortunate inconvenience, sir.
No, please go ahead.
I request RL Ramesh sir, Secretary ICI Bangalore Center, to address the gathering and his inputs on the event that we're conducting.
Yeah. Very good morning all who are online. All for this Engineer Day celebration by Anand Sagar Management. I congratulate the Department of Civil Engineering and the principal, management, and everybody and all the faculty members of Civil Department of DSATM for organizing such a wonderful and fruitful webinar in the eve of Engineers Day 2020. So from the ICI as a secretary, I welcome you all for this wonderful webinar. Today, we have with us eminent speaker. They are going to speak on walling techniques using stabilized mud block. Sir, and the chief guest and speaker of this today is Dr. M.R. Yoganand, founder Minmay Consultancy for mud blocks and building alternatives. Sir, on behalf of ICI, I welcome you for this webinar, sir. And also I welcome the one more a resource person of this day, Mr. A.V. Pramod, Principal Consultant, Miranmai and Mahija Design Consultancy. Once again, I welcome you, sir, on behalf of Indian Concrete Institute for this national webinar. So, ICI is always supporting all the activities of the student chapter. So, by arranging the webinars, by conducting webinars, and then again arranging the speakers. So, if anybody wants to, any speakers of any irrespective of the field, we are ready to support you for organizing such a wonderful. So in this connectivity, the DSATM, the Department of Civil Engineer, has come forward and organized this webinar on walling techniques using stabilized mud box. Once again, I welcome you all for this Engineers Day celebration. So thank you, Dr. K.N. Vishwanath, Professor and Head, Department of Civil Engineering, for giving an opportunity to speak a few words about this webinar. Thank you, sir. Thank you, one and all. I wish you all the best for this
Thank you, Ramesh sir.
webinar. Thank you, sir. Over to
Thank you, Ramesh sir. Thank you, Ramesh sir, for your consistent support.
Thank you, sir.
Thank you, sir.
Thank you, sir. Thank you, sir. Yogananda, sir, I'm extremely apologize to the situation to interrupt you in the lecture. Unfortunately, Ramesh sir couldn't connect when we started the program due to technical issues. I apologize on his behalf as well as the Department of Civil Engineering. Sir, over to you, sir.
Absolutely no problem. Welcome everyone again back. So we will continue where we left.
Your slides are visible, sir. There is absolutely no issue with the presentation.
Okay,
We've been able to see all the slides.
Okay, thanks for the confirmation. So what we can do is probably look at embodied energy in buildings. See, we have structural systems. We can call it RC frame building, frame structures, wherein we have reinforced concrete footing, then you have reinforced concrete columns, beams, slabs. So when we look at the embodied energy in an RC frame structure, the embodied energy goes anywhere from 2 to 2.5 gigajoules per meter square of the area of construction. Whereas when we look at load-bearing masonry, the consumption of energy, embodied energy, comes down to half of the frame structure. This is something very, very revealing, and it only says, should we need to revive load-bearing masonry buildings? This is a question we need to answer today. See, in terms of sustainability, when we talk about sustainability, we need to look at the embodied energy of the building first. And then we can go on to the rest of the issues related to, the activities which take place after occupying a building. So very first thing is the embodied energy. When we look at embodied energy, very clear-cut reduction in embodied energy happens in load-bearing masonry structures. So there is definitely a need to revive and see what we should do, how do we take it forward. Well, I have to share my own personal experience when we talk about this particular technology of stabilized mud construction. I was working in University of Science with Professor Jagdish, and during 87, I decided to build my house like anybody else who wants to have their own home. This was in Jayanagar, 9th block, and all the blocks were made at site, so no transportation of bricks. All the bricks were made at site itself using a manually operated press, using soil and cement and lime. So I completed in 1988. When this construction was going on, I had a lot of visitors who were curious to understand what is happening. Some free advice also comes, as you know, when you are involved in your own house construction, you don't have to invite, people will come and tell you whether it is good or bad. So people came and told me, you are building with mud, it will collapse during rains, and your hard-earned money will be waste. However, there were some other curious people who took the block without my knowledge, and they had immersed it in water for 2 weeks or 3 weeks. And then they came back to me and said, well, the blocks look fine, there was no problem. So very interesting feedbacks. This helped me to take these ideas forward and disseminate. Many people came forward and wanting advice That is how Mrinmay started. We had a testing laboratory to test soil and give mixed proportions, which is a very, very important step. Not all soils are suitable as it is. So we need to test the soil and understand. You will get into the details later. This is, this is something I need to share with you. In 1988, you all know HUDCO, Housing and Urban Development Corporation. So they took my house photograph and it was published in most of the newspapers and magazines. They termed it as mini mud revolution in Bangalore. And this also kind of reached many people who were looking for some alternative ideas. And there was some festival of France, wherein again my house was exhibited in 1989. We built our own office building in 93, 94. Completely exposed masonry, as you can see. Even the staircase has been done with only masonry, no concrete, no steel. And even the roof, a lot of people we used to ask whether we can build 3 floors, G+2. So this was a demonstration of G+2 building during the 94, 95, where my house was an example of 2-storied construction. This was a 3-storied construction. So load-bearing masonry, multi-storied are possible. So coming to the testing lab, we do the soil testing. This is all based on the R&D work carried out at Astra with Professor Jagdish helping us and guiding us. So we have a testing laboratory wherein we test soil from different places all over India and abroad and give them a mixed proportion. Then we have manually operated presses called Mardini. Mahimaya got established to sell this manually operated press, very good quality press. So we all know wet strength is something which is important, not the dry strength. When you immerse the material, whether it is bond break, concrete or anything, immerse it for saturation level for 72 hours and then put it in a testing machine and load it to failure and look at load per unit area as the strength. So we all understand that the minimum compressive strength required is around 3.5 MPa. Pramod will go into the details later, just to give an idea about that. Then Mardini soil block press has been used all over India. There are about 1,000 and more machines all over India and abroad, making to make these stabilized mud blocks. We have given a lot of training. This is something which is very important. And we also have designed mechanized presses, semi-mechanized presses, wherein manual operation is limited to mixing and stacking blocks. This is a completely mechanized press on the right side, producing blocks. This is the factory established a year back near Nandi Hills in Bangalore. So they make blocks and sell it. So blocks are available. Centralized production is also possible. This is just to show the potential of the technology. Looking at training, we have been involved in many training activities for artisan training on the job. This is something which is very, very important. We need to work with artisans. We don't want to call them laborers. Artisans' livelihood is very, very important. We need good skills. If that is something which is necessary, then we need to train people. So we have taken it very seriously on the job training of artisans. And this is after the Bhuj earthquake in 2001. I was there when the earthquake shook and I was a witness to many collapses there, both frame structure as well as load bearing. Building has to be designed taking into consideration the issues related to earthquake. So it is possible to design a frame structure for earthquake prone areas. It is also possible to design a masonry, load bearing masonry structure in earthquake areas. This is how it has happened. So there were about 10 to 15,000 buildings built of stabilized mud blocks in the Kutch area. This is after the tsunami in 2004. Again, earthquake is an issue. As you can see, the on-the-job training of artisans in Indonesia happened. This was in Banda Aceh in 2005. Several houses were built with plinth band, sill band, lintel band, and roof band with vertical reinforcement so that the building performs well during earthquakes also. Again, after the 2015 earthquake in Nepal, we have been helping few NGOs and training the artisans there. See, there is a misconception that you need interlocking blocks for earthquake resistance. What you need is an excellent mortar which binds the blocks properly, and what you need is the horizontal bands and maybe vertical reinforcement depending on the earthquake zone. We conduct hands-on workshops. This is very, very important, wherein we invite people who are interested in it. There is no pre-qualification. We do it with both theory and practicals. November 6th is another workshop we are going to have in this year. So we invite whoever is interested to participate and understand. Very informal discussions happen, and a lot of question and answer sessions happen. We also have a 3-day workshop on not only walling, roofing technologies also. This is taken from the Grama Vidya NGO, where we are involved in conducting a 3-day workshop. This is held in Kaushalya Shale in Kengeri. There are few pictures of students and others trying to build walls, masonry, ramparts, and all. With this introduction, I would like to leave it to Pramod to take it forward. One of my main interest is to see how best I can spend time with youngsters and see how they can take it forward. This is very, very important. We want to get a better hold on what is sustainability, how do we take it forward, how do we integrate many of the alternative ideas into a building. So now I leave it to Pramod to take it forward into the details of the technology, how the block is made, how rammed earth is done, how stabilized adobe can be done without a machine, a cob wall construction, an age-old technique, how we can, like the DVG's Mankuti Manakaga, Haleberu Hosachiguru. I think we need to look at what was traditional, vernacular, and what kind of improvements we can make to suit the present day contemporary requirements. This is something which is very, very important. And mud concrete is another area wherein we are seriously working, wherein we can utilize all the kind of wastes, whether we want to call it waste as a resource is something which is again debatable. You have many factories. Some of the factories have fly ash as a waste coming out of the factory. Aluminum factories have red mud. Foundries have return sand. And building and demolition waste is a recent phenomenon happening in urban situation. A 20-year-old, 25-year-old building gets demolished because of the lifestyle changes, and that gets used to fill the low-lying water bodies. This is something we should seriously look at. A demolished building should be the resource material for another building. This is something which we can seriously work on and take it forward to help ourselves to seriously look at how sustainable, how much value we can give to the word sustainability. Thank you. I leave it to Pramod now.
Thank you, sir. Friends, in the next set of slides, we will try to get ourselves introduced to all these alternative techniques of walling construction. So before we go into the technology as the main thing, we'll try to look at what are the materials we normally use in these kind of techniques. As the topic itself suggests, we are trying to work with stabilized earth, which means soil is the basic material. So any kind of soil can be utilized. Testing of soil is a very important criteria. So depending on the soil availability, we can try to look at which technique suits in that particular situation. Then we add sand or sand-like material if it is required. For stabilization, we use cement, or lime or a combination of cement and lime. We use water. Then, as Sir was mentioning, these technologies have a potential to utilize a lot of industrial waste which are generated from the industries, like it can be fly ash, granite fines, foundry sand, any of such things. And our recent focus is basically on trying to utilize the construction and demolition waste back into the construction. We'll try to look at what are those techniques in the following slides. So first, if we try to understand how the soil is, soil can be broadly classified as expansive and non-expansive soils. And we focus all our attention today in this presentation on non-expansive soils. So soil, we basically have sand, silt, and clay. Depending on the particle sizes, they are being classified. So these are the percentages of sand, silt, and clay, which are recommended for using in these kind of techniques. Say, for example, if we go towards the northern part of India, we have very high silty soils. So we can allow silt up to 35%, and we can limit the clay up to 15%. Sand would be around 60 to 75%. So in today's presentation, we are going to share our experiences working with these 4 techniques, as Sir was mentioning. So the first one is stabilized mud block, where you use a machine and try to do blocks at the site so that you avoid transportation. Then we can also use the same mix to do a wall in situ. Instead of making a precast brick or a block, you can directly build a wall. That technique is called as stabilized rammed earth. Then we can make bricks or blocks using a very simple hand mold, and you call that as stabilized adobe technique or a cob technique. Then the last technique, which utilizes the construction and demolition waste or the waste which are generated from industry, we have termed that technique as mud concrete. We'll try to look at how we are going to produce blocks using all these techniques. So first, we'll try to look at stabilized mud block technique. So this is the machine which is used to make stabilized mud blocks. It is called Mardini soil block press. It's a manual press. It doesn't require any electricity. It weighs roughly about 180 kilos. It can be dismantled into 3 parts and can be easily transported to the site. So the 3 parts are like this. You have a lever attached to a plunger. Then you have a basic frame. Then you have a mold which is interchangeable to achieve different shapes and different sizes of blocks. So we'll now get into the process of trying to produce stabilized mud blocks. As we know, soil also has gravels in it, so we need to screen the gravels initially. So you use a 4 mm mesh, which is practically available. Try to sieve the soil on a 4 mm sieve, separate out gravel from the soil. You can also use mechanical sieve shakers. So once the soil is separated, then as per the laboratory proportions, you try to utilize soil. Whether if sand is necessary, we try to add sand in a required proportion. And to that, you add stabilizer. Stabilizer is cement in majority of the cases, or a combination of cement and lime. Minimum 7% of cement is recommended as a stabilizer. And depending on the strength required, the stabilizer content can also vary. Like concrete, we can also have different grades of blocks being produced, right from initially starting with 3.5 MPa, which is the minimum requirement. You can have a block which has a strength of around 15 to 20 MPa. Recently, with the advancements in the machines, with a mechanized press, we have been able to achieve a strength of around 15 to 18 MPa. So once the soil, sand, and the stabilizer are mixed in dry condition like this, to that you add lime slurry. So here what we do is, instead of adding water, we add lime slurry. Lime slurry is produced by utilizing burnt limestone and trying to convert it into a slurry form. The amount of lime slurry you add to the mix is roughly about 12% of the total mix. The amount of lime which goes into that will be hardly around 0.2 to 0.3%. So then you mix it uniformly. So when you add water or lime slurry to the mix, it has a tendency to form lumps. So all the lumps have to be broken, and then the water has to be distributed uniformly all through the mix. And once the modified mix is ready, you weigh that particular mix before you pour it into the mold to ensure you have a proper density maintained at the field, because density is directly proportional to the strength of the block. So if we can achieve a constant density at the field, we are ensured that we have a good compressive strength, whatever is desired. So once the mix is weighed, we put it into a mold like this, and then you have a compaction stroke. So in the compaction stroke, when the lever is being pulled down, the plunger moves from the bottom and compacts the mix under a pressure of about 12 tons. So once the mixture is compacted, it is immediately taken out. The block is ejected from the mold like this, and then you keep the blocks for stacking. So here, the fresh or the green strength of the block is given by clay which is present in the soil. And when we stack, we try to take precaution such that the blocks are stacked close to each other in order to avoid evaporation losses. We try to cure the blocks. Here it is not being burnt. We try to cure it because we have added cement. So wherever we add cement, we try to cure the block for about 28 days. But after 10 days, you can start using the blocks in the construction because we add mortar in between the blocks. The mortar also gets cured in that process along with the blocks. So this is the process of curing at the site. You can have gunny bags, you can have hay straw, you can have polythene sheets. Any of such methods can be implemented in the field condition. So these are different block sizes which are available with the same machine by interchanging the mold. Normally, we design masonry walls. Like in regular concrete construction, we design the frame. Here, we design the walls to take care of the loads. So there are two methods of design in masonry. We fix the wall thickness and then ask the question, what should be the strength of the block to take that load? Or the other way around is you already have a material with a known strength. Then you back calculate what should be the thickness for that particular strength to take care of the loading condition. In cases like to around 230 millimeter or 9 inches and back calculate what should be the strength of the block which is required to take care of the loads. So these are the possibilities with the same mold. You have inserts to produce blocks of different shapes which are used for different purposes. Then you can also have blocks with pigments, like you can have red oxide, black oxide, yellow oxide, or if you have any product as a industrial waste, like aluminum factory produces red mud, even that can be utilized as a pigment in making blocks. These are all the possibilities. You can also do interlocking blocks by having a mold. One important thing which we need to address in today's context is earthquake resistance of any structure. So we can also make masonry a good earthquake resistant building by introducing features such as horizontal and vertical erections depending on the zone in which we are working. Say, for example, if we come to a zone like Bangalore, which is in zone 2, which is least prone, we need to introduce bands at plinth and lintel level, which is more than sufficient to take care of the lateral forces. As we move to the higher zones of earthquake, the number of horizontal bands increases, along with the provision for vertical band as we move to the severe zones. So this is one typical example of a plinth band, which is being done at one of the sites in Bangalore. What is very important is you don't need too much of a steel. to introduce earthquake resistant feature. It is more to do with the detailing of the steel, what has been used. So if you observe in this slide, what we have done is we have tried to continue the steel reinforcement in two directions, perpendicular to the direction of the plinth beam. So here the rods are bent like an L shape to a distance of about 3 feet. So this ensures there is a proper overlap, and this also ensures there is proper continuity at the junctions, so that in case of lateral movements, the whole structure behaves as one unit and moves as a box without getting separated. So this is a typical T junction which is being seen. You can see the top rods are being continued. Similarly, you can have L junctions. And also the bonding pattern, when we use such kind of a block, here we do what is called a stack bond rather than English or Flemish bond, because we have 9-inch thickness with one single unit. What we need to ensure is that your vertical joints should be discontinuous. So what we do is we always start the corners with a half brick and ensure it is done in both the directions in alternative courses. That ensures you have broken the joints. Then you can also have connection between a 9-inch wall, 4.5-inch wall in order to ensure proper stability of the wall. So this is a junction of a 9-inch wall and a 9-inch wall. This is how you do it. And all our buildings, we normally do not plaster. We always say plastering is done as an excuse for our bad workmanship. If you don't build a wall to a proper plumb, the common excuse is you do plastering on both the sides and bring it to a proper plumb. So in that condition, whatever is the wall thickness, either 9 inches or 8 inches, will become close to around 10 or 11 inches after plastering. So what is very, very important in a wall is trying to seal the joints in between the blocks with a rich mortar. So that process of finishing the joints with a rich mortar is called as pointing. And pointing is normally done using a composite mortar of the proportion which you see here. So if you observe in the mortar, we have added soil and lime. It's not a regular cement mortar. It's a combination of cement, soil, sand, and lime. We call this as a composite mortar. We normally don't prefer to use a cement mortar directly because, as we know, as we add water to the cement, within half an hour that mortar mix has to be consumed. But practically, in site condition, if we observe, the mortar will be used for a longer period, more than 3 to 4 hours. So what we need to ensure is we need to work with that mortar for a little longer duration. So when we add materials like soil or quarry dust or sand, it ensures it delays that setting time by another 1 hour to 1.5 hours. Then all these materials can hold moisture within them. So that provides proper bonding in the cement mortar, which will be helpful in hydration or process also. So there are two types of pointing. One is called as groove pointing, where you can see each and every brick demarcated. You also have what is called as flush pointing, where you seal all the joints in flush with the block so that your wall is in flush. So by doing that, we are trying to avoid cement to a larger extent. As Sir was mentioning, as per we have a code for using mud blocks in construction. It is IS 1725, which was revised in 2013. So we normally say it should have a wet compressive strength of around 3.5 MPa. So whenever we mention the term wet compressive strength, we mean to say that the blocks were saturated for a duration of 48 hours before it was tested under a compression testing machine. So this ensures the block gets completely wet, and it is the worst condition that the building can undergo during a flood. So once the building is submerged, it should have enough strength to carry the loads. So we simulate that condition in the laboratory and then test it under a compression testing machine. And the minimum strength when you obtain that should be around 3.5 MPa. And this strength will vary depending on the loads which it is being experienced. Say, for example, if you want to build a 3 or a 4-storied structure, the same strength can go up to around 10 MPa. So we can do a mixed design in such a way that we can get blocks of different strength by modifying the proportion. So now we will look at some of the examples which have been done using load-bearing masonry structure using mud blocks. So this is an example of a 4-story load-bearing masonry structure which was done in Katriguppe. The wall thickness here was 190 millimeter, not even 230 millimeters. So these are some of the examples where we have used mud blocks even in basements. So this only says that any of the masonry unit can be utilized in masonry in basements. Only thing is you need to ensure you do proper waterproofing. So here the advantage of pre-compression, which is being exerted by the upper floors, is being taken in the design consideration, and the wall thickness in the basement is also kept as 9 inches. So this is another example of a 4-storied residence in Bangalore. So we have used a combination of stone and mud block. This is the central courtyard part. This is in the basement where it has been done with size stone masonry. And we have used stone columns with chapadi stones, stone slabs of 4-inch thickness, 9 inches width and 2 feet length or 1.5 feet length have been used. 4 columns support the central courtyard portion. Then the blocks of different shapes have been used to achieve different niches in the wall. So this is another recently completed farmhouse in Shulagiri where we have extensively used even mud blocks for roofing elements. You can use arches like this to cover up openings so that you can avoid reinforced concrete beams. So this is one of the good examples which we have been implemented in Hyderabad. This is for a school building. Kritika Architects were the architects for this building. The school is around 12,500 square feet. It's a government school which was sponsored by private people. So the entire school construction was done without centering. So we had used concepts such as ferroconcrete for roofing as well as for lintels and plinth. So here, whatever the concrete bands you see, it's all ferroconcrete, and you have reinforcement inside those ferroconcrete as an earthquake-resistant feature. And the roofs were again with ferroconcrete. We had precasted girders with steel, and then we had lifted up the ferroconcrete, which was also precasted at the site, lifted to position, and a screed concrete of 1.5 inch was poured above so that the roofing is also taken care. After this, we have now another school which is coming up close to Hyderabad. It's about 20,000 square feet with the same techniques. So we have completely eliminated the centering from the building. So this is another school building which is in Kanakpura Road. It's for Shibumi. L&S Architects were the architects for this building. A lot of masonry roofing techniques have been extensively used in these structures. We have masonry domes, we have masonry vaults, which have been used as floor slabs. So the first floor here is entirely with masonry vault. So you have covered it up on the top and used as a floor slab. These are masonry vaults, these are masonry domes. A lot of things using masonry have been implemented. So this is another school building in Tiruvannamalai. This only tells us that all these techniques can be utilized for any kind of loading situation. In fact, you have a library at the first floor and you have an auditorium at the ground floor. So it has been designed for the loading condition. Then we have also done a lot of work at Gudalur, which is in the foothills of Ooty, where you have received a lot of rainfall. So this is an example of a 4-story hospital building which has been done there in Gudalur. The basements are done with stone. The upper 3 floors are done with mud blocks, which are 1 feet thick. All the standards which was to be followed for hospital buildings was followed here. with the same slab thickness of 1 feet for different conditions. So this is the first phase. This is the second phase of the same hospital. So this was done in Maharashtra in Govardhan village in Wada. So this was done for ISKCON. Biome was the architects for this building. A lot of their construction was done using stabilized mud blocks. We have implemented even a masonry staircase where you don't have steel and concrete in it. It is built out of bricks and mortar. So this shows, as we have quite enormous potential with masonry, it is up to us how we try to explore those potentials. Here in the roofing, we have jack arches with mud blocks. You can see an arch to take care of the openings. A lot of things have been tried. So as we were mentioning, we can utilize a lot of industrial byproducts in these kind of techniques. This is an example of utilizing a foundry sand from Breaks India Private Limited in Sholingur, with whom we have been associated since past 2.5 decades. Even today, we are trying to do some work with them. So they have a foundry division where they get sand from the furnace called as return sand. It will be very blackish in color. So disposal of such sand was a major issue. So we tried to test those sand and try to arrive at a proportion of mixing it with soil and making mud blocks out of it. So you can see the color of the mud block is very blackish because we have used foundry sand. And this is a school building which we have built using the same blocks. It's a 2-storied structure with a provision for one more floor. Then we have used mud blocks extensively. This is their administration building. This is their meeting hall with filler slabs, again with mud blocks. This is the latest extension of their admin block, where we have done roofing also with mud blocks with jack arch roofs. Another example of utilizing mud blocks is on a large scale is with Nirmiti Kendra. This is done in Devanhalli for Bangalore Nirmiti Kendra, which is a rural Nirmiti Kendra. Their entire admin building was done with alternative techniques. You can see a masonry roof at the entrance. This is a vaulted roof. Then you have masonry jack arch roofs. All the kind of techniques have been utilized in this building. So we have also used stone in combination with mud blocks where we have a lot of loads. So as sir was mentioning, in Gujarat, post-earthquake, we have close to about 15,000 houses using all these techniques, which we'll be discussing in today's lecture. So this is in Meghalaya. This was for their Science and Technology Council. One can try to see the earthquake-resistant features being incorporated in the buildings, as I was mentioning, in the form of bands. This was in Indonesia after tsunami. You can see horizontal bands at plinth, sill, lintel, roof, as well as in the gable. And then you can have vertical bands at different positions as per the requirements, depending on the zones. So this is how we try to make a masonry structure earthquake resistant. So we have seen making of mud blocks and trying to build a wall. So there is another technique called stabilized rammed earth, where you don't do blocks. Instead, you try to build a wall directly. So many of the architects are fascinated about this kind of technique because they can create variation in patterns in the same wall using different colors of soils. So the technique is very simple. We use a mold for ramming the earth inside. The mold can be 2 feet in length, or it can be 4 feet in length, 8 feet in length, or even for the entire structure, if you have a repeatability of structure. Then you use rammers. It can be circular in shape, it can be square in shape. So this will be used for ramming the earth inside the mold. So the process of obtaining the soil mix is similar to that of mud blocks. You sieve the soil, mix it with stabilizer and sand if it is necessary in dry condition to a uniform consistency. Then you add lime slurry, again about 12% of the mix, and then use that mix in the mold, pour it into the mold, and then start ramming it with rammers. So here, what we do is, if your mold height is 1 feet in length, we try to ram that in 3 layers so that you ensure proper density is being achieved. So you add the soil up to 7 inches, then ram it to 4 inches. That ensures the soil is being compacted thoroughly. Similarly, you repeat it 3 times to complete the height of the mold, like this. So corners can be done like this. Another feature or an extended application is, once you remove the mold, you can sprinkle water onto the surface and then rub it with any of the masonry tool like a float. You get a plastered finish like this. So that process will help the clay to coat the surface and you get a plastered surface like this. If you use different variety of soil which are different in color, you get a layers like this. It can be with any of the patterns. A lot of work are being done on this particular technique. You can use a combination of rammed earth or mud block or any such technique. You can use a little longer mold, which is 8 feet in length, 8 feet in height. This was an example from Tiruvannamalai. So this was one of the earlier rammed earth demonstration from our office in 2003. Biome was the architects for this building. 2 feet length mold was used to do this house. So this is a 3-storied building. Satyaprakash Varnasi sir was the architect for this building. This was in Rajarajeshwari Nagar. Basement is with sidestone masonry. Then you have 2 additional floors and a partly 3rd floor with rammed earth. This was in Tiruvannamalai. Ajay Nityananda was the architect for this building. You can see the usage of a little longer mold. So here in one of the residences in Bangalore, Nilay Patalia was the architects for this building. We have used rammed earth as columns. There are no reinforcements inside this column. Wherever you don't have any accidental loads, you can use this as columns in those locations. This was done in the courtyard part of the house. Square shape, circular shape columns were done to support the slabs. So this entire slab is being supported on these columns. So the column dimension is roughly about 15 inches in diameter. Square columns were 15 inches by 15 inches. So this is how it looks with form finish concrete. This is another thing which we normally specify in all our buildings. Whenever we do roofing with concrete, we have to ensure we get a form finish. Plastering should be avoided completely, because once you do a roof plastering, a lot of things will be wasted because adherence to the roof plastering is little difficult. 25% will adhere, 75% will come down. Again, you use it. At the end of the day, there is a lot of wastage. So instead, what we prefer is to achieve a form finish. And it's an option to have the surface as it is, or you can also paint the surface if you like it. So some more examples of rammed earth house, which has been done recently in Bangalore. You can have niches, all such things. This is in another farmhouse construction at Chittoor. Kritika Architects from Hyderabad are the architects for this. So what we have done is we have used U blocks, mud block U blocks at sill level and lintel level. This has helped us to tie the building at those levels for earthquake resistance, as well as to take electrical conduits at the horizontal levels around the wall. And wherever you need vertical conduiting, while ramming the earth itself, you have pipes so that chasing is completely avoided. So you'll have a gable roof here with thatch, and you have a provision for a roof band here, again with U blocks. Again, this building was completely done without any centering. You can see ferroconcrete channels being utilized for that purpose. So this is now receiving the roof. About 9 inches to 1 feet thick thatch roof is going to be done over this layer. So this is an example from Gujarat. As I was mentioning, if your project has a lot of repeatable structures, you can afford for a little longer mold. So here in Gujarat, after the earthquake, we had circular houses. You traditionally call them as bungas. This is about 15 feet in diameter, 3.5 feet in height. So within 2 days, your walls were up to the roof level. So this helps us in the speed of construction. So this is how the finished bunga looks. So those were the two techniques. The third technique, which we are now going to discuss, is with reference to stabilized adobe or COP technique. We might have heard of the term adobe. Adobe is traditional brick, which is sun-dried. So we now have a similar technique, but we have used a stabilizer to stabilize the mix. So the process is like this. You add sand to the soil if it is required. You test the soil, arrive at a proportion, and then mix the soil with sand if it is required. You add cement in the dry condition, mix it thoroughly. Then you add lime slurry. Here, the amount of water you add is roughly about 16 to 20% of the mix. So once that is done, you try to bring the soil to a particular consistency by pugging it with your legs. So what you do is you add lime and then lime slurry and then pug it with your legs to bring the soil to a particular consistency. It's like a potter's job where you bring the soil to a consistency and mold it to the shape, whatever you require. So then you have a very simple mold like this for whatever dimension. It can be 12 inches, 9 inches, 4 inches, 9 inches, 7.5 inches, 4 inches, or whatever it is. So once you pug the soil, bring it to a particular consistency, you fill the mold with that soil, and then you try to demold this on a hard surface like this. Since we have used a little more moisture, so we try to demold it on a harder surface and leave it for about 24 hours so that it gets properly dried. Cement would have taken its role by then and it becomes harder like this. And after 1 day, you can keep the blocks for stacking and cure it. So this is the process of stacking. You get different sizes and different shapes of blocks. So this is an example of a two-storied construction using stabilized adobe in Bangalore with a provision for one more floor. So this is an interesting example, a project near Jigani. About 25 houses were built using stabilized adobe. So before those houses were built, the villagers were given centralized production units, and we said we don't have any role there. So then there was a lot of discussion, and we told them we will train one person from each house in the block making process so that the villagers only produces the blocks, and in that process the cash flow will be within the community, and also they gain the skills. So once they did that, in order to bring confidence in them, a community center was built with the help of same people along with masons. So by looking at this, they got quite a lot of confidence and they decided to build their own houses using the same technique. And the same technique was also used in Meghalaya with collaboration with UNDP. A lot of houses have been built using this technique. This was an example in Gudalur for a two-storied residence with a provision for one more floor. Again, one more doctor's residence in Gudalur. So this is a three-storied load-bearing masonry construction using stabilized adobe in Bangalore. Biome was the architects for this. It's a load-bearing masonry structure. There are no columns, but you have a small amount of beams to support the openings. We have utilized a lot of alternative roofings also. So this is how it looks. So this is another residence in Coimbatore where we have used the same adobe even in the roofing for masonry walls. So this is some example from Malnad College of Engineering, Hassan. A yoga center and a meditation hall was built using stabilized adobe technique. Professor Subhash Basu, who was heading the architecture department at MCE, was involved in this. So this is a masonry pyramid, 22 feet by 22 feet in plan, which was done completely with stabilized adobe technique. The amount of concrete and steel used here was very, very less. So we also have a project which is getting completed in Gujarat. This is again for TVS Group. It's called Flow Metallic. Their administration building was completely done using stabilized adobe technique. So this is now in the finishing process. So it's an option just to paint the surface, as I was mentioning, without doing any plastering. So another improvement of the same technique is called as COP construction. Traditionally, we can see this kind of construction in a lot of places in India. So this was a project in Madhya Pradesh near the Kanha forest area. Traditionally, they had a technique of COP construction since centuries. So when we got involved in the project, we just wanted to make sure their technique, which was survived from several decades or several centuries, needed some small intervention with the upliftment of the technique. So we decided to introduce them to a technique of stabilized COP. To the traditionally followed technique, we just added cement as a stabilizer and we gave them that technique. An improvement was made to have a proper mold on one side or a sheet on one side so that you get a smoother surface. On the inside, the walls were finished with hands so that you get the rough finish. So from the outside, due to the sheet placement, you get a very smooth finish. On the inside, you have that hand finished walls. And these are the constructions which are going on in that place. So this is how it is from inside. We have used a lot of masonry units, even in roofing. So that was a technique called as stabilized adobe or COB. We now move on to the last technique, which is called as mud concrete. This technique, as I mentioned, is basically arrived at to utilize a lot of construction and demolition waste which are being generated. So in today's context, we tried a lot of people demolish the olden buildings, not because they are structurally bad, but due to change in lifestyle. And we don't know where that debris goes. It can go into a landfill, it can go into a cover to cover up the lake or in things like that. So according to us, there is a potential to utilize all these things back into the construction without sending them out of the site. So let us see how we do it. So these are the materials which we normally use. What we try to do is we try to process the construction and demolition waste into sand or fine aggregate and coarse aggregate. The construction demolition waste can be with concrete, it can be with masonry, it can be with plasters. So you try to process those wastes and try to utilize it in the construction. So we use soil, We use fine aggregates, natural as well as processed. We use coarse aggregates. We use cement and lime, again as stabilizers. So the construction and demolition waste is being processed here. You can see in this example, the bricks, the waste bricks have been processed to fine and coarse aggregates. Concrete is being processed to fine and coarse aggregates. Nowadays, we also have some industries which can process the regular C&D waste into fine and coarse aggregates. So once we arrive at a proportion of mixing all those materials, we try to use a conventional concrete mixer and mix it like a concrete. So once we have the concrete mix ready, either we can do a precast blocks, or we can do a shuttering and then pour this concrete like what we normally do with regular concrete to build an in-situ wall. So if you want to do it like a block, you have a very simple mold like this, and then you fill those molds and then leave it on the surface for about a day. From next day, you can start stacking these blocks. So we have tested quite a few of these blocks, and it has given us a strength of up to about 10 MPa. So we can do a proper mix design to achieve that strength. So once we stack those blocks, we try to cure properly. Again, because we have added cement, we will try to cure it for about 21 to 28 days. But after 10 days, we can start using it in the construction. You add composite mortar, so the mortar also gets cured. In the process, the blocks also gets cured. So this is one of the ongoing projects in Hoskote, where we have used mud concrete blocks as a walling unit. This is a proposed construction for one more story, so it's going to be a 2-story load-bearing masonry construction with mud concrete blocks. In another project recently, we have used the same mud concrete technique even for roofing with panels, which has been used as beam panel roofing concept. So this is another example in Sithilingi in Dharampuri districts in Tamil Nadu. So the house, what you see here, is newly built. You had an older house here, which was about 20 years old. The entire house was demolished, and all the demolished waste was reused back into the new construction. So none of the waste went outside the site. So that is the potential of this technology. So this is how it was being built. A combination of blocks and in-situ technique was adopted. Then an example of a cowshed was done at Mangaluru. Subhash Basu sir has been involved as an architect here. It was also painted with some artists. Nirmiti Kendra also has some demonstration unit using mud concrete techniques. So again at Sithilingi, there was a school construction which was started, and there were a lot of well digging process inside the village. So in that process, we generated quite a lot of soil which had a lot of gravel in it. So if we had to use that kind of a soil in all the 3 techniques which we discussed earlier, then all the gravel part was considered as a waste. So we choose the mud concrete technique and utilized all the gravel particles into the construction. So these are some of the structures which was done using mud concrete technique. Another important thing to be noted here was they had spent close to around 30 to 35 lakhs for the school construction, and close to about 25 to 30 lakhs was within the village. The cash flow was within the community because local artisans were employed, local material was employed. Very few amount, like 5 to 6 lakh, was given for steel and some amount of concrete which was purchased, or cement which was purchased. So these are some of the constructions of the school. Majority of the buildings are with mud concrete. So at the last part, we'll try to look at what are the different proportions we normally use for our construction. Like I was mentioning, all our proportions of mortars and leveling concrete will have a combination of soil and lime. So PCC, what we normally call as a leveling concrete, we normally do it in the proportion of 1:4:8, where 1 is cement, 4 is fine aggregate, and 8 is coarse aggregate. Instead, in all our sites, we try to use this proportion, which has a combination of soil and lime. This PCC is used in foundation. This PCC is used in flooring. So everywhere, wherever you have that as a leveling concrete, we try to use this as the proportion. Sorry. Then we have different mortar proportions for side stone masonry. Then we have different proportions for wall construction. Depending on the earthquake zones, even these proportions will be varied to match that particular zone. Then if you are doing any masonry, vaulted or a dome construction, you use a richer mortar mix, like whatever has been produced. And then for pointing, we have already seen the proportion. So before I conclude, I would like to say that I was also a student of Professor Lakshmikant, sir, at BIT. So he had taught me basics of electrical engineering when I was doing my bachelor's at BIT. So thank you, sir. With that, I'm just trying to conclude this presentation. If you have any questions, maybe we can take those questions.
Thank you, sir. Thank you, Pramod sir and Yogananda sir, for the wonderful presentation. Lakshmikanta sir apparently is not here. He left for a meeting about few minutes back. I think he would have been really happy to know that you are his student. Anyways, I'll just convey the message to him, sir.
Yeah, thank you, sir.
Thank you. Students, a wonderful presentation done. A lot of information was there for grabs. So if you have any queries, you can post it to Yogananda sir as well as Pramod sir. If you have any issues with the connectivity, you can as well type down in the chat box, and I'll read out the question to sir. Yes, anyone?
Sir, this is Osama, sir.
Yes.
Sir, I have a query.
Yeah,
Sir, when we use mud blocks, right? When we use mud blocks, so as a load-bearing wall, as external walls, so what happens? It gets exposed to atmosphere, no, sir, and then it causes, growth of bacteria in them. So that will be more like unhygienic. So how will you counter this?
Well, is this a question based on experience, or you're just asking out of curiosity?
Well, curiosity, because like we are developing, right? We are going towards much more sustainable. So,
Okay, I will put it this way. In our experience, if you look at any material used for construction, whether it is concrete or laterite or stone or mud blocks or burn brick, if you travel from, let us say, Goa, you take a trip down to Kerala, the coastal belt road, as you come, you will notice most of the buildings look very green. There is mass formation on any kind of material. Mass formation will not differentiate between concrete because they won't bother. They just need some dust and moisture to grow. So all the compound walls, in fact, okay, even the mangrove tile roofs, which is a burnt product from a factory, you will have mass formation on it. So it is more of a how would you look at your own building to look in terms of issues related to dampness and things like that. If you are very concerned of the surface which is exposed to rain, Then what you can do is you can apply a clear coat, which is called a silicon clear coat, which is available in any hardware store. It will not allow the surface to absorb moisture, irrespective of the material. You can apply it on a clay tile, you can apply it on a mangrove tile, you can apply it on a mud block also. So that way, it will help the surface not to absorb moisture, and issues related to mass formation will be avoided. If you still have any more doubts, you can come back.
No, sir. Thank you, sir. Thank you so much.
Okay, welcome.
Sir, Yogananda sir, there is another query
Yeah.
from a student. His name is Ratan. So he's
Yeah.
really interested in the cost aspect of the brick.
Yeah. So this is interesting. In fact, when we look at cost, how do we understand cost? I think that is where we should begin with. For example, let us say you are replacing burnt brick with these stabilized mud blocks, wherein you have a burnt brick wall, then you plaster both the sides, then you do what is known as primer, putty, and then you paint it on both the surfaces. You look at the cost per square feet of the wall area. So many things go to complete a wall, wherein you can understand what is the cost per square feet of the wall. Here, you use mud blocks. You don't need to plaster both of them. You don't need to paint it also. It is possible that you can leave it exposed if you like it. There is quite a bit of cost difference between the two. And also, you conserve material. This is very, very critical for us if you look at sustainability. Sustainability is a direction where you conserve material, but it is fine to employ people and give them livelihood and improve skills. This is where you will cut down at least by 25% of the wall cost if you take stabilized mud blocks with good quality block and good pointing of the joints and leave it exposed. So there is every possibility of reduction of about 25% in the wall cost per square feet of a finished wall. You have any more doubts?
I think you've aptly put it that sustainability takes precedence over anything else. Environmental issues takes precedence over any other factor. Sir, I myself have a small question. Yeah, I think Deen Dayal is also has a similar question that I have. He's posted in the chat box. When I saw the PPT, I saw buildings which were about 2 floors, or I think that was the maximum. Is there a restriction on the load-bearing wall? If I'm using the mud blocks as load-bearing wall, is there a restriction on the number of floors?
I will leave it to Pramod. He has shown it. I think maybe he will remind you. Yeah.
So there is no such restriction, sir. We have also shown you in the slides 4-story construction.
Oh, I probably missed out. So, but there is no restrictions as such. You can have any number of floors.
Yeah, you can see those examples in the West. You have load-bearing masonry of up to 20-30 floors.
Okay.
So
Then I think I missed that slide. I think I missed that slide. Yes, sir. Thank you, sir. Students, is there any other questions?
Spend some time showing you the slide so that we get a better understanding of the things. See, this is a building which was done about 25 years back.
Sir, I think the slides are not visible.
Okay,
I think,
we will try to get that.
Yes.
Yes. Okay. So this is a 4-story load-bearing masonry building, 190 mm thick wall. It is not even 230.
Oh.
Okay, this was done about 25 years back in Banshankari, say, 3rd stage, Bangalore.
Okay.
Interesting situation was this. He was very keen on building a load-bearing masonry. He didn't want a frame structure. And he looked at materials available in Bangalore, which will give him the required strength. So there was no material other than stone wherein he could use it, which is locally sold here. If you want to go bricks, you need to come from Kerala those days. So this technology has the potential to give you more strength required. It's a question of mixed design. For example, you have concrete wherein you do the mixed design and get strengths of different grades, right? Like M20, M30, M40. It can go up to any grade depending on the requirement.
Yes, sir.
Similarly,
Yes, sir.
here, we do the mixed design and ground floor needs a higher strength. We go for a higher grade. In this example, it was a 10 MPa block, what was used in the ground floor. So in the
Okay.
first floor and second floor, subsequently, it reduces, the requirement is less because loads are less.
Yes,
So
sir.
it's up to a structural engineer who understands load bearing wall design and he can give solutions depending on the proposed building.
Yes, sir. Yes, sir.
And this
Sir,
is some example from the West, where you have multi-storied load-bearing masonry structure.
okay.
So this is a 16-story, and these are some of them.
Yeah, just to give some examples outside.
Yes, sir. Yes, sir. Sir, also, could you just throw some light on what are the say difficulties that you actually face while constructing such buildings? A few, just to name them.
See, one of the most important, activity what we are involved in is in skill development. See, the skills are dying. That is one of the major issue. We consume more materials, but skills are dying. For example, you take one brick wall with both sides plastering. They don't build it to plumb, and your consumption of material for plastering also increases. Wherein a 9-inch thick wall will measure about 11 inches or 12 inches once it is completely finished. So,
Exactly.
lot more consumption of material because lack of skills.
Yes,
So
sir.
skill development, artisan livelihood is the direction wherein we need to invest on.
Yes, sir.
So the challenges are actually to help the artisans to understand this and build it properly. And the whole process of mud block making, if one understands, I think it's not a rocket science to do a very good quality block.
Yes, sir. Yes, sir. Thank you so much, sir. Any other doubts? I think Ratan again has a point to make. He says that stabilized mud blocks make architects more artistic and engineers more flexible while designing.
I
I
think
any views on that?
Yeah, there is a lot of scope for architects and engineers to utilize this technology. In fact, it can give them a lot more opportunity to try masonry structures. In fact, India is a country wherein we have demonstrated excellent load bearing masonry structures before, and even now you have 300, 400-year-old buildings which are still being used. For example, I visited IIT Kanpur a few years back, and they took me to a temple completely built out of masonry. No steel, no concrete. It is just brick and mortar. And it is 1,500-year old. Beatergaon temple, just brick and mortar. So it can survive. But I would like to add one thing: buildings have to be maintained. That is very, very important. So that particular temple was taken by Archaeological Survey of India. They are maintaining it. If you don't maintain a building, irrespective of any material it is being used, there will be issues. You convert a good quality building to a conservation project if you don't maintain it. That is the
Yes.
stance of affairs.
Yes, sir. Yes, sir. Thank you so much, sir. Thank you, Yogananda sir and Pramod sir, for sparing your valuable time with us.
Thank you.
Excellent presentation. There were a lot many concepts to learn. I think students would also agree to the point that there is a lot of activities, research activities that could be taken up. Uh, that could be
Yeah,
taken up with regards to mud block. I now request our beloved HOD sir, Dr. K. N. Vishwanath, to address the vote of thanks.
thank you.
Sir, very good afternoon. Sir, Namaskara, Yogananda sir and Pramod sir.
Namaste,
Namaste.
sir.
Sir, we have met earlier when I was in campus
Yeah, yeah.
one, sir. Kumarsam Levatal, we have met and
Okay. Correct.
we had one conference also.
Yeah, yeah.
Sir, very nice to have you here. uh, our team was taking forward, so I just kept it at the back end. So just
Yeah,
back. So when they are capable and they can do, we need to push them forward. So
correct.
that's what I've been doing.
Absolutely. Nice.
Sir, starting from 1988 with your struggle and then embodied energy in the materials and then eco-friendly construction to the present scenario, Yogananda sir, you took our students through a journey of the mud blocks constructions. Then you showed through the pictures and even Pramod sir through the pictures of the buildings, and you showed that this mud block technology will be the trend in the days to come, because giving the scarcity of fine aggregate and cement and sand, cement production 1 kg ಗೆ 800 gram carbon dioxide ಆಚೆ ಬರುತ್ತೆ. So now we are on to cut short that ಅದೆಲ್ಲ going on. So as you said, fly ash is also coming in. Hangagi, this is the natural thing. Sir, I have one question. I'll ask at the end, sir.
Yeah,
So,
yeah, yeah, yeah.
and what are the requirements for these constructions and how to take it up? That Yoganda sir, you said it. And then later part, Pramod sir gave us a detailed explanation on the raw materials, the different types of molds, and then manual preparations, then the bondings, the vertical and horizontal bondings that need to be taken care, and a real insight into the final year students who will be in another 6 months will be going out. So you've given enough feedback into that. And then number of examples, buildings you said, and what are the characteristics that has gone into that? Prati building ತಗೊಂಡ್ರೆ ಆ building ಅಲ್ಲಿ ಏನ್ characteristic, ಏನ್ specialization ಇತ್ತು ಹೇಳಿದ್ರಿ sir. So that was real good thing for our students to understand. It's a very well laid out presentation. Sir, ನಮ್ಮ ಕಡೆಯಿಂದ ನಿಮಗೆ ಹೃತ್ಪೂರ್ವಕ ಧನ್ಯವಾದ. It was very nice presentation. Thank you so much. Our students have really taken a lot home back with this technology. ಸುಮಾರು ICI ಮೆಂಬರ್ಸ್ ಕೂಡ ಲಾಗಿನ್ ಆಗಿದ್ರು ಸರ್. ದೇರ್ ಆರ್ ಅರೌಂಡ್ ಟೋಟಲ್ ಒಂದು 5 ಜನ ಬಂದಿದ್ದಾರೆ ಸರ್. ಅಂಡ್ ಟೋಟಲ್ ಅಬೌಟ್ 210 ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ವರ್ ದೇರ್ ಟುಡೇ, students and faculty of other engineering colleges. Sir, thank you once again on behalf of the institution DSATM and on behalf of department staff, faculty and students. So I thank you wholeheartedly for your time sparing. I know you are very busy because our conference time ಅಲ್ಲಿ 2-3 ಸಲ ಭೇಟಿ ಮಾಡಕ್ ಬಂದಾಗ you were there on the field. ಆಮೇಲೆ ನನಗೆ ಸಿಕ್ಕಿದ್ರಿ ಮಾತಾಡಕ್ಕೆ. So thank you so much, sir. Nice of you, Pramod sir, Yogananda sir. Sir, nice.
Both of us enjoyed it. Thank you.
Sir, thank you, sir. Thank you. So we'll catch you up later, sir. We'll meet you once we do that.
Sure, definitely. We will.
Sir, thank you.
All the best.
Sir, thank you so much. Students, it's nice, and hope you have taken things. And with the permission of Yogananda sir and Pramod sir, you can definitely meet them with their prior permission and appointment for any doubts. Even the next new 5th semester students, you will be taking their project works and technical seminars. Definitely, you can have some guidance from them apart from what we give here. So that is one thing. Okay. And dear faculty, thank you so much for all your support and coordination. Sandhya madam and Meghna madam, the coordinators, and Girish sir, who helped them through and through, and Vinay Kumar, Hari Kirtan, all of them. Okay. Thanks, faculty, and thanks for the good work. So thank you once again, Yogananda sir and Pramod sir. Thank you, sir. Nice. So with your permission, we'll end the program, sir. Thank you.
Thanks.
Yeah, Girish, to you, Girish.
Yes, sir. Once again, on behalf of the Department of Civil Engineering, I thank both Yogananda sir and Pramod sir for a wonderful demonstration of how we can convert what is considered as waste resource to something which is so very useful and have a very broad environmental sense of it. And sir, I think when Yogananda sir started the lecture, he stressed on the fact of going back to traditional things and coming back to vernacular architecture. I think that is the need of the hour, wherein we can learn from our forefathers what they did and how sustainable they were. And I think that was the whole premise of the lecture today. I would like to thank Dr. K. N. Vishwanath sir, the head of the department, for encouraging us to take up such activities. And always he's at the helm of things and organizing, taking much pain in organizing such events. Thank you, sir. Thank you, sir. We wish to continue this legacy for years to come. Thank you, sir. And also, students, thank you so much for your continued patience and listening to the lecture. We hope to have furthermore webinars and seminars to ensure that there is a lot of knowledge transfer, which is the need of the hour. And also, like Yogananda sir stressed to the fact that there is a lot of laxity and there is a lot of lacuna in the skill that is there. And rightly said, the skill is something which all of us have to ensure in the days to come to ensure that we progress in our career. Thank you all for the wonderful program happened today. I think with the permission of the organizers, Meghana ma'am and Sandhya ma'am, we can conclude the session. And students, there'd be a small feedback link that would be sent to you. We request you to ensure that the feedback for the same lecture is provided at the earliest for documentation and further processing. Thank you. Sir, can we log out?
Yeah, students, thank you so much. Yeah, one second, Girish. Thank you, Girish.
Yes.
Students,
Yes,
thank
sir.
you so much for your consistent presence all through the technical this talk. So since 10:30 till today, till now, you are there through and through. Thank you so much. That shows your real discipline and interest in the subject, and it gives us more energy to do such activities more and more to you people. Okay, it is nice. Today ಇವತ್ತು ಸರ್ ವಿಶ್ವೇಶ್ವರಯ್ಯ ಅವರ ಜನ್ಮದಿನ ಅಂತ ಆಚರಿಸ್ತಾ ಇದ್ವಿ. ಇಟ್ ವಾಸ್ ಆನ್ ಸೆಪ್ಟೆಂಬರ್ 15 ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಟುಡೇ. ಹಿ ಸೇಸ್ ಒನ್ಸ್ ದುಡಿಮೆಗೆ ಗುರಿ ಇರಲಿ, ದುಡಿಮೆಯಲ್ಲಿ ನಿಯಮವಿರಲಿ. That means you should have a goal for your working, and then let have principle or policies be there during your ದುಡಿಮೆ ಮಾಡುವಾಗ. ಸೊ ಅದೇ ತರ ಓದುವಾಗ you have some goal to while you start reading, what you have to read, how much you have to read, what I should achieve, and then while reading also have some discipline. ಇವತ್ತು ಇದು ಓದೋಣ, ಇದು ಅದು ಮಾಡೋಣ, ಇದು ಮಾಡೋಣ, I should learn this, I should learn that, I should expect this. ಈ ಥರದ್ದು ಇಟ್ಕೊಂಡಿರಿ. Okay, never cease to ask question. So once you stop questioning, you cease to learn. Madhuri. Okay, and I should once again thank all my colleagues, Sandhya madam, Meghna madam, and Girish, who supports them always, and all the faculty who are there. Okay, the entire department is good, and they are with you people. We will do something good in the days to come. Okay, okay, we'll have some good name for the department always. Okay, you achieve good things, you study well, and any support from our end, we are always there. Okay, thank you, students. Thanks again, Girish. Girish?
Sorry, sir. The links, yes, sir. The links will be provided to you in the class groups. You can access the links from that. Now, I can say that you can all exit the meeting and look forward to your classes further. Thank you, sir. Thank you all.
Thank you, Pa. Thank you. Thank you all. Yes.